So the y prime is dy dx. So you're going to do your separation of variables, meaning you're going to get your y's with your dy and your x's with your dx's. So the first thing you really want to do is rewrite this to show that. Right. And then you always want to move your, you never want your dy or your dx in the denominator. You always want that outside of the denominator. So in this case, when you move this guy around, you would get like 1 over y dy equals 3 over 2 plus x dx, something like that. And then you're just going to do your antiderivative now. So you're going to do this guy here. For this piece, this is just the natural log of y, right? And for this one, you're going to get 3 natural log of 2 plus x, something like that, plus c, right? Keep in mind that you can bump this over here, right? So you can say, just rewriting it, ln of 2 plus x cubed plus c. And you're solving for y here, so you want to get rid of your ln, and you're going to just do the e of both sides there. So you have y equals, and this is e to the ln of x plus c. And remember, if you have, when you have like bases and you multiply them, you add their exponents. So basically you could rewrite this as e to the c times e to the ln of 2 plus x cubed, right? Because if you have like x to the 1 plus 2, that's really just x to the 1 times x to the 2. Like it's just like that. E to the c, that is a constant, so you can just make that your c. And then e to the ln, those are going to cancel, and you're going to get 2 plus x cubed equals y. We're doing what we did in the first 3 examples, or at least example 3, where we do separation of variables, but now we have an initial condition. So this means that I can now go back after I have solved for it and plug in my initial condition and get an exact or a particular solution. And so it says, given the initial condition of y of 0 equals 1, find the particular solution of the equation xy dx plus e to the negative x squared, y squared minus 1 dy equals 0. All right. So in this case, they already have your dy dx out, right? In some cases, they won't. And so we're going to do 2 examples. This one where they have it, and the other one where they worded a completely different way. And I want you to pay attention to the wording, because that's what throws you off on a lot of tests, is the wording. So for this one, we're going to do the same thing. We want our x's with our dx. We want our y's with our dy's. And so like for this one, the first thing I would do is just move this guy over. So I would subtract that over. E to the negative x squared, y squared minus 1 dy equals negative xy dx. So just move him over. And then we're going to do some dividing here. So I am going to divide that y over here, and I'm going to divide that e to the negative x squared over here. So it will cancel there, and I'll have y squared minus 1 over y dy. And then this will cancel here, and I'll have negative x over e to the negative x squared dx. We'll talk about that in a second. So these both look not pretty at this point, right? And so we're going to simplify them a little bit before we move on. So on the left-hand side, we are going to do what we would have done all along. We're going to divide each piece by that y. So we're going to say y squared divided by y, right? Minus 1 divided by y, dy. On the right-hand side, the negative exponent actually moves it. So this whole thing's going to bump up here because it's a negative exponent. So on this side, we're going to have negative x e to the x squared dx, all right? And we can simplify this piece of it right here to what? Y squared over y? Just to y. So y minus 1 over y dy equals negative x e to the x squared dx, all right? And then we're going to take the antiderivative. So, you know, our whole goal here is to find y. That's what we're trying to do. And so we need to then do the integration piece of it. Integration of y, you just add an exponent divide, so that's 1/2 y squared. 1 over y, that's going to be ln of y. Over here, we have to consider the exponent x squared. So if we did like u substitution and my u was x squared, my du would be 2x, but I need -1. So we are going to multiply by -1/2. So it would just be -1/2 e to the x squared. And then, of course, we have our plus c.
Wait, can you repeat that?
So if we go back to our initial condition up here, y of 0 equals 1. That means we are going to plug in a 0 for x and a 1 for y. So a 0 for x and a 1 for y. So I'm going to say 1/2 1 squared minus ln of 1 equals -1/2 e to the 0, right, squared, plus c. All right? Just plugging in a 0 and a 1. And of course, this is easy. 1/2 times 1 squared is just 1/2. ln of 1, log, any base of 1 is what? What to any power equals 1? 0. So your log of 1 then is always going to be 0. Equals e to the 0 then is 1. So we have 1 times -1/2 plus c. So if I solve for c, c here is going to be just 1, right? So I'm going to take that 1 and I'm going to plug it in for my c. So I have 1/2 y squared minus ln of y equals -1/2 e to the x squared plus 1. In this case, since you have like an x squared and a y squared, just get them all on the same side and leave the constant by itself. I will say, and they did this, and I would agree with this here, they multiplied everything by 2 to get rid of those fractions. So we multiply this by 2, you get y squared. This by 2, you get 2 ln of y equals -e x to the x squared plus 2. And then move this e guy over. Move him over. So you get y squared. What can I do with this 2 here? It's in front of my natural log. What can I do? Yep, so minus ln of y squared plus e to the x squared equals 2. says find the equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at the point xy as shown. And they give you a picture, but you don't need a picture. So here's the deal. If they gave you what the slope is, the function of slope, then they gave you dy dx because the slope is the derivative, right? That's how we have found slope from like day 1. So if they gave you slope, the equation of the slope, that's what they gave you right there. That's the first thing you need to recognize, okay? Then they said that goes through the point. That can be used as an initial condition. Now, it's not an initial because it's not a 0 starting point, but it still is like when they give you a point slope and you go through and you plug in your x and y. So you're still basically going to do the same thing. You're going to separate your variables, antiderivative, and plug in your 1, 3 to solve for your equation, all right? But this is worded completely different. So I don't want you to see this thing worded this way and not know it's the same exact problem, because it really is. Obviously, it looks a little bit different. So we'll end up with like 1 over y dy equals 1 over x squared dx when we get those separated the way they're supposed to be. And then antiderivative here is going to be natural log of y equals negative 1 over x plus c. Again, we're solving for y here. So you want to do your e, your base e, to get rid of your ln, and you would do something like that there. And so on the left-hand side, you're left with just y. On the right-hand side, remember if you have e to something plus something, it's just e to that power times e to the other power, like that, all right? And this is where you're going to want to replace this guy with just c, right? So y equals c e to the negative 1 over x. And now we can plug in our 1, 3. So we can plug in 1. It's negative 1. That's a negative. It just kind of got hidden in there.
So does the e move to the bottom? Because the exponent is negative?
It will, once we do, let's go ahead and plug in our numbers and then you'll see what it does. All right, because it'll work out. So we are going to plug in our 1 and our 3. So we're going to plug in a 1 for x and a 3 for y. So 3 equals c e to the just negative 1. All right, which is the same thing as c over e. So if we're solving for c, c is going to be 3e. All right, and then we're going to plug that back in to our function here. So we're going to say y equals 3e times e to the negative 1 over x, right? Well, we have two bases, same bases, so we are going to add those exponents, right? So we want to add the 1 and the negative 1 over x. So you end up with y equals 3 e to the 1, and we're adding these, so plus a negative, so minus 1 over x. And that's not, they just got a common denominator here. That's all they did. So we have y equals 3 e to the x minus 1 over x.